Welcome everyone. In this video, what we're going to do is we're going to learn how to name covalent compounds. They're also known as molecular compounds. Now, there are some differences between naming a covalent compound versus an ionic compound. If you recall, an ionic compound is a metal and a nonmetal. And what we said is that the metal stays the same and the nonmetal ends in "ide." Well, the difference when you're naming a covalent compound or molecular compound is we're going to use a system of prefixes that was not used when naming ionic compounds. Now, the prefixes are listed below, okay? And remember that a covalent compound is a nonmetal with another nonmetal. And when we name them, the first nonmetal will stay the same. You will not change that name. However, the second nonmetal, just like you did with ionic compounds, we're going to change it so that it ends in IDE. Now look at the prefixes below. Mono is the prefix for 1. Di is the prefix for 2. Tri is the prefix for 3. Tetra means 4. And then the rest are more like geometry. Penta is 5. Hexa is 6. Hepta 7. Octa 8. Nona is 9, and deca is 10. Now, there is one little rule that I'm going to emphasize, and it has to do with the prefix mono. You see, we do not have to use the word mono if the first nonmetal appears once. You do have to use the word mono for the second nonmetal, but not for the first. I'm going to give you an example, okay? So let's say you had CO. Carbon and oxygen. These are two nonmetals. So the first nonmetal is carbon, and normally there's one of each, so you would say monocarbon. And then the second one is oxygen, which you would use monooxygen, right? Or oxide in this case. I'm going to show you what we're going to do here. Monooxide. There's a couple of things I want to show you here so that you can name these and spell these correctly. First, the first nonmetal, if there's only one, like in this example, do not use mono. So instead of saying monocarbon, you are simply going to just say carbon. Then secondly, a lot of times when there's a double vowel, to smoothen out the name, you're going to see that one of the vowels is removed. So instead of saying monooxide, you're simply going to say monoxide, just like that. Carbon monoxide. Now, we're going to do a bunch of other examples so you could see how this works. All right, so let's say we had, let's go over another sample problem here. We just saw that that's carbon monoxide. Now you know where this one comes from. So we got carbon monoxide. Whoops, wrong spelling. Let's fix that up. So we got carbon monoxide. And this one is still going to be carbon, but now you got two oxygens. So the prefix for 2 is di. So you're going to say carbon dioxide. And that would be the name for this one, okay? Let's look at a couple more examples. Let's say you had SO3. There's one sulfur there. So don't say monosulfur, just say sulfur. And then the prefix for 3 is tri. So remember the oxygen will end in "ide, so we know it's going to be oxide, but there's 3 of them. So it's going to be sulfur trioxide, just like that. Okay? Look at this next one. There's 2 phosphorus and 5 oxygens. Okay? So we do need to use prefixes for both. That mono only applies for the first one and only when it has 1. Here there are 2 phosphorus, so the prefix for 2 is di. Remember that the first nonmetal stays the same, so it remains as phosphorus. So you're going to put diphosphorus, and the prefix for 5 is penta. Okay, so instead of saying pentaoxide, when you have that double vowel, you'll realize that to smoothen out the name, they'll remove one of the letters, usually from the prefix, and the vowel removed will be the A, and it'll simply be pentoxide, just like that. Okay? So that's diphosphorus pentoxide. Let's take a look at a couple more examples. We all know this is commonly called water. But technically, the name would be, there's two hydrogens, so the prefix is di. So this is dihydrogen, and this has one oxygen. We do need to use mono here. Again, instead of saying monoxide, okay, we're gonna remove, let me go ahead and fix that. We're gonna remove one of those O's, okay, just like this, to smoothen out the name, and it'll simply be monoxide. So the technical name for water is dihydrogen monoxide. Now let's take a look at another one. And notice what all of these have in common. They're all two nonmetals. That's how we know they're covalent. The minute you know it's covalent, you are going to use the prefixes. Okay? If there was a metal present, or a polyatomic, that would not make it covalent. That would be ionic. And if it's ionic, you do not use prefixes ever when it's an ionic compound. You only use prefixes when it's covalent, which means it's two nonmetals put together. So here we got carbon and chlorine. Now there's only one carbon, so we're not going to use mono. We're simply going to call it carbon instead of monocarbon. The prefix for 4 is tetra. So this one is going to be tetra. And then remember, chlorine will become chloride. That second nonmetal always has to end in "ide." So it's carbon tetrachloride, just like that. Okay? Let's take a look at a couple more examples. Why don't we go backwards this time? I'm going to write a name. I'm going to put here phosphorus. And I'm going to put here pentachloride. And so notice there's no mono here. So phosphorus pentachloride, phosphorus is simply just P. Penta means 5. Chloride comes from chlorine. So there are, chlorine is your second one, and there are 5 of them. Notice this is very straightforward. This is not like ionic compounds. Remember that to obtain a formula for an ionic compound, what you do is you set up the metal and the nonmetal, you find their charges, and you crisscross. There is no crisscrossing here. The name goes with the formula. There's no mono here, so there's only 1 P and 5 Cls. So there is no crisscrossing involved here. Another thing that you're going to notice, and I'm going to show you on this next one, okay? Let's put here dinitrogen tetroxide. So di means 2. Nitrogen is N, so there's 2 of them. Tetroxide comes from tetraoxide, which is 4 oxygens. So here's oxygen, here's 4. Notice, do not reduce a covalent compound. You only reduce ionic when you crisscross. There is no crisscrossing here, so there is no reducing. You see, the name the name depends on the prefixes. If you were to reduce this to NO2, you completely change the name. This is now called nitrogen dioxide. Okay? So do not reduce these. The name depends on the prefixes, so it stays. I know it could be reduced to 1 to 2, but when it's covalent compounds, you leave the name as is. Okay? Let's try one more here. Let's try here sulfur, hexa, fluoride. So here, sulfur is S. There is no mono in front, so there's only 1 sulfur. Fluoride is fluorine. There's 6 of them. So we're going to put the symbol for fluorine and we're going to put a 6 here. Again, very straightforward. There is no reducing. There is no crisscrossing. These are not ionic compounds. We are sharing electrons. And when you're naming covalent or molecular compounds, remember it's two nonmetals together. They depend on using a system of prefixes. Okay? The first nonmetal, like sulfur here, stays the same. The second one will end in "ide." And the only time you don't use a prefix is when the first one has 1. You do not need to use mono. You would not call it monosulfur hexafluoride. Okay? If the second one has 1, that's when you do use mono, as we saw earlier with water. This one is dihydrogen, and it's dihydrogen monoxide. Here you would have to use the prefix mono. Okay? So keep that in mind so that you don't confuse the two systems. Ionic compounds will never, ever use prefixes. Only covalent ones will.